afternoon, good evening, or good morning from wherever you're joining us from today. My name's Sarah and I'm the Program and Event Manager at the Reactor in Sydney, Australia. Welcome to a Microsoft Reactor Sydney live stream event. Today will be our third episode of our In the Cloud, tripping over my words again, In the Code Garden series with our cloud advocate, Renee Noble. So over the next couple of weeks or the next week, we will talk you through everything you need to get started on your Python journey. So firstly, a bit of background on Renee. So whoever's joining us for the first time today, we've had 2 previous episodes of this series. Renee is a self-proclaimed Jane of all trades. She's worked in government doing ML and Python backend, full stack in the ed tech startup sector, and dabbles with embedded tech. In her spare time, she leads the Girls Programming Network for women and girls to realize their potential as techies. She's also started a business to help bring exciting coding opportunities to kids and teachers. Besides teaching and tech, she loves swing dancing cats and having a ridiculous number of plants, which you can all see behind Renee there.
Inspiration some for the Code Garden. Just some of them, it's true. Sarah knows the full. She knows the secrets.
So for today, we'll be talking for about 20-25 minutes or throughout, with some time for questions at the end and throughout. So do ask us those questions in the comment section and we'll try and answer as many as possible. And at the conclusion, we'll share with you a link to our feedback survey with the event code and also a link to the additional resources, which we've already put in the comment section there, and a link to the YouTube channel, which you'll be able to view this session straight after today on demand via that link. But for now, I'll hand the floor over to Renee to begin. So thank you so much, Renee, and over to you.
Thank you so much, Sarah. Very excited to be here for episode 3 of the Code Garden, the Circle of Life using loops in Python. We're going to talk about a few different kinds of loops today. So we're going to kick it off with for loops and looping through strings. Then we're going to use loops with different kinds of data, talk lists, we'll talk dictionaries, and talk like why some things can be looped through and why others can't. Then how to loop with numbers. And then I've got a secret, like my hot tip of the year for loops as well. Getting yourself some numbers and some data at the same time. We'll get to that. And then while loops. So it's going to build off what we did last week with our Booleans and if statements. So today in the Code Garden, we'll be using Visual Studio Code. That's the IDE that I'm using. It's got heaps of useful stuff. And we'll use the Python extension of that. It's super useful for using Jupyter notebooks, which we'll be using for lots of our demos, as well as Python files, because they let us do input, which is just handy for demos. So repeating code, that's what this episode is all about. And yeah, we're going to talk about this because it's really a core principle of coding. As soon as you start writing any, quantity of code, you really want to have some loops going in there. For instance, you're coding a game of chess or something like that, you're going to want to have a turn, whereas, a set of things that can happen during that turn. And then you're going to want to repeat that for the other person's turn and just repeating that until the game's over. You might want to repeat something a certain number of times. I've got our 3 wishes genie here, but maybe you want to give someone 3 attempts at a password, or maybe you want to go through a shopping list or some sort of table of data, and you want to do the same thing for every single line. You don't want to be writing that code, for every single line. Read this line, do this thing, read this line, do this thing. You want to use a loop to do that 100,000 times for every line of data you got there. And it just, helps keep your code cleaner, neater, and that's what we're going to talk about today. So, that did 2 slides at once. So first up, we're going to start by talking about looping for each thing. So we're going to start off with strings because we've been working with strings in the past couple of weeks. I will do a little bit on lists and dictionaries. If you could join us for next month, we'll be talking about data types in Python, including lists and dictionaries, so you'll know more about them and what they can do. But from today, you will get to see what one is and how you can loop through it and use it to do multiple things. Keep doing the same thing for each item in your collection of data. So let's jump over to the demo book and we'll get started. So I'm going to jump into our IPython notebook first, where I'm going to do all our little demos before we get to ones that we want to use input for. So first up, let's start just with looping through a string. So I'm going to set up a variable. I'm going to put my name in it. And we can just do for letter in name, print letter. And we can hit run. And that's just going to take, we're going to set our Python interpreter. And it's going to run. Here we go. We get one line at a time, printing out a letter of my name. So you might be like, oh, that's smart of Python. It knows what a letter is because I wrote letter here and then it figured out what the letter is. But I'm also going to show you could like call it anything like apple. You could call it apple and it's still going to work. And we get the same thing again. Let's put another name in. We're going to put Sarah's name in. And then what do we get? We get Sarah. So yeah, it just knows how to split things up, but you don't have to give it any particular variable name here. And what this is just a variable that gets changed every single loop. So we go through this, and then the first loop, it's going to say, okay, apple is equal to S. And then it's going to jump onto the next iteration of the loop. And then we're going to say apple is equal to A. And one more loop, apple is equal to R, and we keep going all the way through the name. So it's just picking up the next thing in what is called an iterable. So iterables are things that you can iterate through, which is what our loops are doing here. So what else can we do with our loops? I'm going to put in some markdown so we can have some notes. This is loops and strings. Loops with strings. Another hot tip about Jupyter Notebooks, you can just put in these little headings in here using the markdown. Just use those hash symbols to get yourself a heading. So we're going to do some looping with lists next. Okay, so let's put it in as the wrong one. We put it in as code. Here we go. Looping with lists. Okay, so we've just seen that done with a string. We could put either the string here as the name, or we could literally just put it here. Let's say Bob. And you get the same thing. So you can loop through a variable string or just the string as it is. But we can also do this with other things. It's not limited to just letters in words. But if you do put a word in there, or even if you put a sentence, if we say Sarah is cool, then we're still going to get it one letter at a time. It's not going to break it up into words is one thing to note. It's always going to do it based on the letters. Okay, so what happens if we do something with a list? So a list is a way of having multiple bits of data there in one variable. So I've got this list of fruits. We can do the same thing, but now for the fruits. So let's say for fruit in fruits. Once again, we could say anything in fruits. We could say for potato in fruits or whatever we want. And we're going to print yummy fruit. Okay, so here we get yummy apple, yummy banana, yummy pineapple. So once again, it knows how to split it up. It's not because we said fruit, when it's not because we said item in the list or something. We could call it a fruit itself. And it's not going to be like, oh, I'm confused because that is a fruit. It's going to say, okay, this is the name of the variable. You could call it anything you want. I could call it Renee, name it after myself. If you gotta put your variables everywhere though, and we get it to work again. And we add more things to the list. We go grape, and it will do another thing. So it's super convenient because if you want to be adding more and more things. So that's another really convenient way. And if you had a list of data, maybe you have a bunch of readings from some sort of sensor, it'd be a great way to process them. And you can put really any logic you want inside of this loop. So I could say, if P in Renee, because that's what I've called them now, which is normal. If P in Renee, then we're going to print something out. And we don't get banana because it doesn't have a P. So we can do anything we want in there, and it's not limited to like any size. Like you could have the entire code for a whole game in here and just repeat it for each turn. So yeah, it's really handy for repeating whatever you want of whatever size you want. So one more fun little data-based one is with a dictionary. So we're going to say looping with dictionaries. I've once again put it in code, not markdown. That's okay. We need the code one in a second too. Here we go. Looping with dictionaries. So We did have a little sneak peek of a dictionary last week when we had Zach guest starring, so he's making a recurrence in our dictionary. We have our hometowns. So once again, we can go through our hometowns for name in hometowns. And you'll see the reason I'm going for name in hometowns rather than like pair or like Renee, Sydney, pair of name, location or something. And it's because it's actually just going to give us the keys, which are those first values on the left. These ones here. Because that's how, when we iterate with a loop, it's just going to give us the keys. So you're like, well, what if I want all my stuff? Because I've put the other stuff in there for a reason. So let's get another copy of that and pop that down here. And we can turn this into a different iterable. So by default, the iterable for hometowns for a dictionary is just the keys. But maybe you want everything, actually. Let's go with everything first. So we're going to say a pair in hometowns. We're going to just print out the whole pair. So we can get the whole pair as a tuple is what this round bracketed thing is. It's like a list, but we'll learn more about that next month as well in our first episode, which is about lists and tuples. But we get the whole thing then because it's giving us an iterable, which gives us one of these at a time. There's one more thing we could do with that, which is, let's grab that again. Well, there's actually probably a million more things we could do that. But with one more that we're going to do today, which is we want the values. So we're going to say, let's call it city. And we can just get the values. So this is saying from here, give me the values as an iterable. Interestingly, we can't actually just print out this. I'll show you what happens if we do. We do get it. We get it as a dict values. I thought we were going to get it as an iterable. Interesting. But yes, you can see that's what we're getting. It's creating this list that's going through. But yes, I wonder if we go items, do we get an iterable? Sometimes you'll get something that prints out an iterable. This is an iterable, but it doesn't tell you what's in it. But for this one, at least in here, we're getting the whole thing printed out as what we're going to go through. It's really convenient. Other times you might want to print out your, iterable, but you're not going to get to see all of the items in it unless you convert it to a list. But we'll get to that in a second when we get to our numbers, because I've got an example that will hopefully actually hold up for that one. But yes, as we saw, we get these pairs from our dot items, and it turns it into something we can then go through and get all of those items. But we might also want to split it out into each of our items as we go through, because we've got these pairs. Where do we have our pairs? Up here. Have our pairs, but we don't want to have both of them, like they're not in a useful format yet. So I'm going to show you a way that's really great with loops and just generally in Python that you can just expand this. So just for an example, I've got these counts. Maybe we're doing a stock taker in the shop. And let's just say we got counts and we want to look at the first item, which is count 0. So we're just going to call it item. I just want to look at that one. And I could actually go fruit number in item, and it would split it out for us. So if I print out that, oops, we go print fruit num, and then we get both of them. There you go. We get apples and we have 5 of them. I could also just print out one of them. I can automatically split them out from our item because Python goes, oh, that thing's got 2 things in it. You've got 2 things on this side. I can split it out. And obviously, if you put the wrong number of things on either side, then it's going to get mad. It's not going to do what you want. And it'll throw an error. But when you know there's exactly 2 things, you can split it out like that. So we can actually do this with a loop as well. So we can go for fruit num in counts. And then we can just get rid of these ones. Let's say got an F string I prepared earlier. So we've got our F strings, which we did in the first week. We're saying, slot in our variables here. We can say num fruits. So we're going to get 5 apples, 2 pineapples, 10 bananas. So it's split it out into our fruit and our number of fruits, which is super convenient if you want to start doing stuff without having to mess around getting just your fruit or just your number, and just get Python to do it for you. So that's a really handy tip for working with expanding out of unpacking is the technical term for it. Unpacking your tuples or your lists or whatever you have into multiple variables of the right quantity. So that's super convenient. So we're going to move on to looping with numbers. So let's take a look at our slides again. Do make sure you ask questions throughout. Love questions. That's why I'm here, to answer your questions. Yeah. But yes, let's talk about iterables first, because I could jump back here for a second, actually. I could try and say, like, for num in 5, print num. And it will throw an error because it says int object is not iterable. Because it doesn't know how to break it down. Like just with these ones, it goes, okay, this is a list of tuples. Give me one tuple at a time. This is a dictionary. Give me one key at a time, unless I've got values or I've got items. Then give me one value at a time or one pair at a time. And with the string, it knows to give me one letter at a time. But with the number, it's like, I don't know how to go through this. That's not a thing that I can do. So we need to talk about iterables. And basically, iterables are things that it knows how to chop up and go through one item at a time. So for us to be able to do something like going through something and exactly 5 times or something, go through the numbers 0 to 10. So maybe you want something to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or to loop, asking for a password or some information 5 times exactly, then we need to make the number into something that is iterable. So that's what we're going to do next. So jumping back, we're going to fix this one up. So we currently have that we want something to go 5 times, but it does not work because we need to turn this into something that is iterable. So range 5 creates an iterator that goes between the numbers 0 and 5, excluding 5. Because we start from 0, it gives us 5 iterables, 0, 1, 2, 3, 4. So if we hit run, it's going to print those out for us. We can also set this to go from, let's say it starts at 1 and it goes up to, but not including 6. So now we've got 1 to 5. We could even say it starts at 1, it goes up to 6, but it only does every second one. So get 1, 3, 5. So we can create an iterable that goes through those numbers. So what is the iterable, though? This is what I was talking about a minute ago, where it's not going to want to print it out for us, but at least we can see that it can try. So let's just say, let's just get the basic range. And it's just going to be the one that goes from 0 to 5, not including 5. So it gives us this range object. Prints out quite nicely in here. I'm wondering if that's a Jupyter Notebook thing. And because it's just being very polite to us and not like some gross big location or iterable class thing. So that's nice. It's telling us it's a range from 0 to 5, which is exactly what it is, but it's not, as we saw before, the numbers 0 to 5. But we can turn it into the numbers 0 to 5 by turning it into a list, which is just a way of saying, hey, get this iterable, and instead of storing it in this neat way where it just spits out one number at a time, turn it into a list. And with the list, it does take up more memory because you have to be able to store the whole list, but you can see it, which is convenient. But yeah, the iterables are a way of generating the next number, because if we know it's the range 0 to 5, then we just know where we start, and then we can just spit out the next number without having to store the whole list. So that is what our iterables are about. So let's just comment that one out for now. And okay, we've got that. And we can either print out each number in our range, or we could do something a particular number of times. So we could have the same thing. So I've got for I in range 5. It's common to say I or J just as like the iterable this is the marker I'm up to in my counting. And then we could just do something, even if it's just like print hello 5 times. So you might not necessarily want to use the number you've generated, but you do want it to be there so you can do something a fixed number of times. And this is, not limited to just saying, an actual literal number there. We could do it based on a variable. Let's say variables in range. So we could start by having, the number of turns per game, 5 turns in a game, for I in range turns, just as we've done each other week. You can just put your variables in anywhere. We're just going to say your turn. That's not the your I want. There we go. Your turn. As we had above, you could also do something for the length of something. So you could calculate how many things you want to do based on, let's say, a list of places. So we go to our list of cities, and then we can say for I in range, and we're going to use the inbuilt Python function called len, so the length. Get the length of this list. Something is upset about this one. We'll find out when we run it, I guess. So red liney. Okay, all good. Okay, and then we're going to print I. Actually, let's print something more fun. So maybe you're filling in the blanks and you want 4 blanks to fill in for each city. You get this line, and all you had to do was say, hey, get the number which corresponds to the length of this. So you can put any number in there and it will just work. So those are our key working with numbers, but here's my hot tip. And it's called enumerate. So if you're an enumerate fan, get in the chat and give us a like, get hyped for them, because they're my favorite tip for working with loops and data. Enumerate. So sometimes you're going to want to have both your markdown. We want code. Okay, we're going to want to have both the things we had, like what we had here, get the letter that we had in our string, but also you might want the index, because maybe you're working with a second list of data and you want to have both the position that that letter or that item in the list was, and you want to have the actual letter. You don't want to have to go, oh, give me the number, and then I'll go get my own letter out of the thing, because that just seems like a waste of time, because you've said, okay, go through all the things based on the length of the list maybe. Give me the numbers 0, 1, 2, 3, 4. And if I have that number, then I can go and say, hey, go to my list of places and get me the 0th thing. But that seems like a waste of time, because that seems like a lot of repeating based on, we've already told it what we want it based off and what we want to loop through. All I want is the index, and I want the thing in that position. So that's when enumerate comes in handy. So maybe we had a list of favorite fruits. And we want to say, okay, I don't want only just the fruit. I don't want only just the number. I need both of them. So I'm going to say for I and fruit, as we talked about earlier about the unpacking, in enumerate favorites. So this is going to say, hey, I want this, but I want the numbers, the indexes, which is how we count, 0, 1, 2, 3, 4, 5, etc. Index of each fruit with it. So give me I first, the index. You could call index or whatever you want. And then the fruit, and split those out. And then we could have printing out the fruit. Like that. Obviously, my 0th favorite fruit is mango. That doesn't seem quite right. So I'm going to add a 1 to it to make all of these make a little more sense. First favorite fruit, mango, then blueberry, then strawberry. So that way we had both pieces of data there, and yeah, it's so much faster and less messy, and you just know what you already have and you don't lose track of them. You don't have to make sure they stay in sync. It's just a good one. Jack is in the comments. He also loves them. Naze, Danielle, also loving them with a thumbs up. Thank you, Enumerate supporters. It's a good one. Okay, so let's just jump onto our last concept. While loops. So last week we worked on if statements. So you have a logical condition, which is either true or false, and then you make a decision based on it. And this is a lot like that, except the decision is either keep doing what I've been doing or move on to the next thing. So we have our booleans, our two states, true and false, and we can use any of the stuff we learnt last week about creating a condition. So those are, something is less than something else. Something is equal to it. In strings, you've got numbers. You can even use all the ands and nots and ors we covered as well last week. Got a lot of options. Anything you used last week, you could use again here. So this is what our loop's going to look like. Here's an example that will seem familiar to most people. Ask for a password. Is the password correct? No. Ask for the password again. And you keep doing it until they get it right. And then when you finally get it right, you go, yes, you're in. So this is what I call like an input pattern. So you ask for something first to kind of set up that initial variable, and then you keep looping again to do it. So I've got a couple of different patterns of these ones for you to have a look at. Let's jump to those. But I do want to use input because while we've been doing all of these for loops, they're really great when you have a specific number of things you want to do. While loops are better when you have an uncertainty about when the condition is going to get met. And the easiest way to demonstrate that is with input. So let's give that a go. So let's start with a counter. So I'm going to say we're gathering donations for a charity, and we want to keep going until we've made $50. So I'm going to start by saying this is our counting one. This is a comment. If I haven't covered that specifically already, when you put a hash at the front, it just means, hey, this is for people to read and not computers. So let's start with, we want to keep going while the total is less than 50. So if we haven't reached 50 yet, we want to keep going. But to do this, we're going to start by actually saying what total is. And the total is going to start out at $0 for our total donations collected. So we're going to start out there, and then we're going to say, okay, donation, we want to get a donation. So I'm going to call the variable donation, and I'm going to get them to input how much are you donating. I'm going to then turn that into an integer so I can then add it to our total. So I'm going to say total is equal, say total equals total plus donation, or my hot tip is total plus equals donation. It's the same thing, it's just a bit shorter than that one above there. Same, does exactly the same thing. So this is going to say, hey, we have $0 so far, and then the loop's going to start. We're going to go, hey, do we have less than $50? And we're going to, yes, we have less than $50. We should keep going with the loop. So we're going to ask for a donation. How much are you donating? Turn it into a number and add it to our total. Then we're going to loop back around from the bottom to the top of the loop and say, hey, what's our total? And then it's going to check. So it depends what we've donated so far. Finally, when we finish all that, we're going to say print. We reached the target. That's what we'll say. Okay, let's give it a run. Cool. Let's bring this up. How much are you donating? And I say I'm donating $32. How much are you donating? $5. How much are you donating? $10. And another $10. We reached the target. So we got 32, 37, 47, and 10. Takes us up to $57. It keeps going until we reach that target. We should have printed the total so far as well. But, you guys, you get the gist. You could print out anything in here if you wanted. So print total. Let's just print out the total just for fun. And we can see that. Did it print 0? No, we haven't saved it yet. Classic me. Run. Okay. $30. $50. Reach the target. Okay. It is a little behind on our printing. There we go. It did start off with 0. It's kind of not the order I've expected to print in. Oh, yes, of course, because we ask for the amount and then we print out the total. So we're going to start out by printing out the total. That'll make a little more sense than what I just did. Let's give that a go. Starts by we've got $0. We got $40 now. We've got $5 more, 45, and we get up to 5. We get 50, reach the target. So that's how we can use that as a counter. And then one last one before we wrap up, which is the password loop. So let's say another comment first, password loop. Let's say the password is hello. And we're going to get them to guess equals input password, question mark. And then we go, well, guess is not equal to the password. Then print incorrect. And then we're going to get them to guess the password again. So this loop's kind of different because we do need to have that input above the loop. Otherwise, we don't have any guess because we do have our thing right in here. So it's kind of like we set the total here. And then we ask for the input inside the loop. This is a little bit different because we are not basing it off something that is completely distinct from the password that we can set up separately. So we get that. And then if they get it right, we're going to print you're in. Okay. Yeah, I'm going to comment this one out because otherwise it's going to run that one first. Okay, let's give it a go. So here we go. Password, hat, dog, lemon, hello, you're in. So we've got our password loop there. That's another common pattern where you have the input before the loop and then input repeating in the loop. So I'll pop these all up on GitHub so you can have a look at them all. But yes, let's finish off our slides for today. So that's the end of today and this first bunch of Python instruction, Python streams. But we've got Python data structures coming up in May. We're going to cover lists and tuples in the first episode, then sets, the least well-known but extremely useful data set, data type, and dictionaries, which are personally my favorite and so useful. So yeah, do come along, sign up for those. They're all on the website, on my personal website, and on the Reactor meetup and everything. Sarah will come back and appear again. But yeah, hope to see you next month as well.
Thanks, Renee, and thank you to everybody for tuning in. As Renee mentioned, we have put those links in the comment section there, including the link to Renee's website, which you'll be able to see recordings from the YouTube, which were in previous weeks, and also what's coming up in the next couple of weeks as well. Also added to the chat section was a link to our survey, which you can see there, and the event code 15773. If you have time to fill that out, that would be great. And you can check out the on-demand version straight after today via this YouTube link here. And if there's any other videos you'd like to check out from Reactor previously, globally or Sydney, you can do so via this YouTube link here. And then any upcoming events as well, you can register for them here on our Reactor Sydney meetup page. And I think that's all we have time for today, Renee. So thank you so much. Thank you everyone for engaging with us in the chat. And we'll see you next time for another Microsoft Reactor live stream event. Have a good afternoon, evening, or morning.
Bye, everyone. Thanks for joining and thanks for the comments in the chat.